project manager of the BIRDS program and is one of the persons behind the creation of Myowa. He finished his Master of Engineering in Space Engineering from Kyushu Institute of Technology. From DOST-ASTI, please welcome Engineer Joven Javier.
Good afternoon. So by that, I'll try to make my presentation in summary and more informative, but I hope so. So I'm discussing about the BIRDS-2 program. It's a program incorporated in a master's degree in Kyushu Institute of Technology, wherein a non-spacefaring country will join and merge as a team to be able to build their own first satellite. For the case of Bhutan, yes, this is their first, and for our case, this is our first cube satellite. So the step up will be the replicated program that we will be implementing here in the Philippines. So in front of you is a cube thing. It's a cube satellite. It's the actual flight model that we send on space. It's from the Bhutan, the Philippines, and from the Malaysia. Now, this small thing will be a big thing soon, because this mission will not last on space, but the future sustainable space program. And why do I say that this thing will be going to be a big thing soon? Because this little thing is a low-cost satellite that we can be able to send into space. So when we started this development, we thought it's going to be hard. And yes, there's some point that it will be going to be hard when we develop this satellite. But what we found out is this small satellite can be used for educational platform and proliferation of education. So education that will be able to make a human resources to sustain the space program. Because otherwise, the pictures that we're taking from space from our own satellite will just be an history. It will not be able to proliferate our knowledge and know-how to build the satellite. So when we launch this satellite in space, so the one milestone that we achieved is when this satellite passes to the ground stations, when it is deployed, is this noise. Okay, that noise might be annoying, but it contains information. So when the satellite passes, it serves as a heartbeat. So at the same time, it also contains information that can be decoded as telemetry and other information incorporated on that, what we call CW Morse code beacon. So when this satellite was deployed, and one of the questions or comment that I saw on Facebook is, we already got a microsatellite in space, then why we go to nanosatellite? Okay, so we already go to a 50 kilogram satellite, and then why we go down to 1 kilogram? So the answer is, of course, it's low cost. It can be used in educational platform. Imagine, with respect to Diwata, it's a microsatellite. It's much more complicated and big, and it's much more high cost than a CubeSat. If you build a microsatellite to proliferate educations, you will build 9 teams, for example. But if you're able to break down the microsatellite into a cube, which is a fraction of that cost, you can be able to 9 times 5 teams that can be able to make and know how to build the satellite. Since the process of making the satellite is the same as making us the microsatellite. Second is, you can put an experimental module and technology demonstrations. A module or a commercial off-the-shelf that never will fly in space will be put on that. So if you put that kind of experimental module into a high-cost satellite and then it will not work, then it's a waste of money. And unless you will put it in a low-cost satellite, so you will see if that is successful, then you can use it for much more better experiments. So, 4 reason is constellation is possible. So if you have a budget of this and you want a better revisit time, for example, a communication, you can build 20 and put it on constellation. And one thing is development is short. We just made this CubeSat in 1 year. I think we delayed 2 months, so it's just 2 months is delayed. So, but the target to build satellites just 1 year, strictly. So they're trying to make it a lean and a standard that CubeSat should be developed in 1 year. And it can be used as a milestone for a country to build the first homemade CubeSats that we are targeting next year. So the BIRDS program consists of the BIRDS 1 from the other country, the BIRDS 2 where I used to be lead of that team, and the BIRDS 3 we're currently launching this year their satellites, and we're participating on the BIRDS 4. So these programs provide an opportunity to learn the entire process of the satellite cycle, from mission planning up to the satellite disposal. And this one will lay down the foundation for the sustainable space program of each country, and to create an international network of ground station and to assist the infant space. So, in the BIRDS program, we already have ground stations. This is a continued collaboration with the country, na kapag dumaan yung satellite mo, whether it's built here, the other satellite ground station on the other part of the country, since this is amateur ground radio stations, they can accommodate and get the data, or they can make an uplink of that. So we have a network of ground stations. So this is the advantage that we have when we join the BIRDS project. Now this is the flight model of the Myowa. So from that knowledge, we know how to build from outside up to the inside and know how to make the design of the satellite. And the lean development was taught to us how to make the satellite in 1 year. So, process will be simple. We will use the heritage as much as possible. So we took a time to research what component is already in space. If not, we will go further for testings such as radiation, vibrations, and thermal vacuum, just to verify that this commercial off-the-shelf component will work on space. And we work on this as close as possible, that we are trying to replicate in UP340. So the clean room, so the laboratory, the ground station and testing facility will be as near as possible. To avoid emails, to avoid messages, so pag may kailangan ka din sa isang tao, just go right through that person without waiting an answer for an email or message. If you want to test this thing, just go to facility. So we're bounded by 30-meter radius when we work on that satellite. So the team is composed of 2 Filipinos. So Adrian is still in Kyushu, so to finish his doctor, and we have 4 Bhutans and 2 Malaysians, and a Japanese. So we divided in certain subsystem when we worked on that, and this one is multidisciplinary. Not all is electronics engineer or electrical engineer. Two of that is a civil engineer. So this is the real development happen when this is behind the scene of what happened during development. So we have the mission definition phase, the preliminary design, the critical design, the flight model, and the safety review to JAXA. This is all the stages that we have to come through to the development. And this is the actual schedules that I created and summarized when we developed the satellite. So as you see, everything is very compressed within a year. So, ang sabi nga sa amin is may utang pa kami na 2 months kasi lumampas kami ng 1 year because of that delay of something. So, this is the actual phases. When I was assigned as a project manager, the satellite should be targeted to be finished by December when we start the kickoff meeting by November. But when I see that there's a civil engineer and need to learn the electronics and programming, the problem is we have that red line. So we projected that we will finish the satellite by programming. And we will finish the MDR by on time, but except for the VDR because there will be a learning curve with the other team. We cannot integrate things because others still learning. So that is what the real behind the scene when we do the satellite. So of course, honestly, there's some mistakes with the design. Of course, yun yung hindi nakikita sa labas because it's the final product that we have. So there will be mistakes. And that mistakes will be a delay because naglalags ka dun sa time na yun. And then there will be an experience like the design rush and these mistakes on the fabrication side. So yun yung isang bagay na nakikita nyo as reality ngayon sa fabrication side at saka sa part na nagdi-design. So, one cause of that is the language barrier because we do it on the Japanese way. And iba-iba yung culture namin, language namin that time. So, this is Kyushu Institute of Technology when I was graduated, I get my degree, and we do the Myowa there. And this is the University of the Philippines, and we will do and try to finish the flight model by 2020 of March next year. And maybe soon, we will not stop with 1U, but rather with 2U or 3U or more than that. And as a stamina for space, I'm under with the project of the Step Up, which is the space technology, proliferation and education through partnership, university partnership. And this is the 8th scholar where the secretary is mentioned. So, pwede niyo tandaan yung mga mukha na yan because this 8 will be the first 8 scholars that we will send the first homemade satellite of the country. So, mission statement is just like that. So, you can do that. And lastly, this one. We try to lay down the foundation, the sustainable space program of the country, and we accumulated the human resources and industries. So this is the business forum in terms of space, and business deals with industry. And the main one component of that industry is the human resources that knowledgeable and know how to do things in space. That's all of my presentation. Thank you.